Hello everyone, welcome to the channel. We have a cubic x cubed plus I is equal to 0. I is the complex unit, the square root of -1. We will show three different methods. The first one, actually I will just talk about but not show the process. We can call this x some a plus bi, a standard complex number, and plug this into our equation. We can cube this a plus bi, add our I, and equals 0. Equaling a complex number to 0 means the real part will be equal to 0 and the complex part, the imaginary part, will be equal to 0. Using these two equation, a system will be solved for a and b. Then our complex number, actually our roots, will be found, x plus bi. The second way, we'll try to use factorizing our cubic and find our roots. Now, my friends, this x cubed plus I cannot be factored in this way, but remember we have I cubed is equal to negative I, or we can say I is equal to negative I cubed. So for this I in our equation, we have actually x cubed plus I. This is equal to 0 now. We can say x cubed minus I cubed is equal to 0. Since I cubed is equal to negative I, and negative times negative will become positive I. Now we can use the difference of these two cubes. We can say x minus I times x squared plus x times I plus I squared. This is equal to 0 now. So the first root from here is equal to I. You can check I cubed plus I in the original equation. I cubed plus I cubed is equal to negative I plus positive I becomes 0. And we also have a quadratic now. Let's solve this. We have x squared plus xi plus I squared. This is equal to 0 now. I squared is -1 by definition. Let's write x squared plus I times x minus 1 is equal to 0. We will solve this for x by the quadratic formula. X is equal to minus b becomes negative I plus minus the square root of I squared. This is -1. Let's write -1 minus 4 times 1 times -1 becomes plus 4 divided by 2 times 1, which is 2. So we will have x is equal to negative I plus minus root 3 divided by 2. Or more precisely, we can write in terms of a plus bi form, x is equal to plus minus root 3 divided by 2 minus 1/2 times I. These are the complex roots, and x equals I is also a complex root. So the set of solution becomes this 3 complex number. This is the second method. Let's talk about the third method. That will use the polar coordinate. We have x cubed plus I is equal to 0. So if we separate this x cube, this is equal to negative I. And negative I is equal to e to the power of I times 3 times pi over 2 using the Euler's notation. Let me show you. Negative I stands here in the complex, in the imaginary axis. We have real and imaginary axes. The length r here is 1, and the angle, the positive principal angle here, theta, is 3 pi over 2. So we have negative I is equal to e to the power of I times 3 pi over 2. Now we can write our roots. X1 is equal to e to the power of the 1/3 of this becomes pi over 2. And this is just I. The second root will become e to the power of I times pi over 2 plus 2 pi over 3. Since we have 3 roots, we will rotate our root by 2 pi over 3. So this becomes e to the power of I times, I guess, 7 pi over 6. And this should have a negative real and imaginary part. This should become negative root 3 divided by 2 and negative 1/2 times I. And the third one is equal to e to the power of I times pi over 2 plus 2 times 2 pi over 3. This will become e to the power of I times we will have 8 and 11, I guess, 11 pi over 6, and that should be the other root we have found from the quadratic formula, root 3 divided by 2 minus 1/2 times I. And this is the other solution. There may have another solutions you can find. Thank you for watching and see you in the next videos.